Hello, beautiful scholars. I hope this finds you well and excited for your celebration of knowledge. I'm going to do a quick review. Let me be clear, this is not sufficient. This is not all the studying you're doing. You need to make sure you understand the homework. I highly recommend you come and check your answers in the key, form study groups, read over your notes again, etc. Okay? So there are 3 standards on this test. One of them, A, says students can use the kinetic molecular theory. We haven't used that term a lot, but that's basically everything we've talked about particles. It's a little thick. Let me make that smaller. To model and explain the behavior of gases, and model means diagram, and you know we've done that a lot. So first off, let's just make sure you know the vocab words that I would expect you to. Of course, gas particles. You want to be able to discuss the main variables, pressure, volume, and temperature. And you want to discuss what goes along with that. So for instance, pressure, you always want to talk about collisions. Volume is the amount of space. Temperature, you want to talk about kinetic energy and the speed of particles. I don't think we've done a good job of discussing this throughout the unit, but as part of temperature, this standard also addresses absolute zero. Okay, and I can guarantee you need to know about absolute zero, so make sure you know about that. Okay. As far as diagramming goes, if you're making a diagram, I would pay very close attention to 2 things. The number of particles and the speed. And depending on what variables you change, each of these might change. So for example, if I want to draw something that's at a low pressure and low temperature, then I would draw very few particles because there can't be many collisions. And low temperature would mean they're not moving very fast, so I would draw very small arrows. Okay. And then if I wanted to explain this, I might say in this container there are very few particles. I think your explanations, they tend to flow a lot easier if you always start by discussing the particles and what you know about them. So there are very few particles, and they have a low kinetic energy. So they move slowly. Since they move slowly, they do not collide with the surface often, and the pressure is low. Okay, so that's just one of many examples that we've now done together. You can check the notes. We did a lot of experiments, my attempt at making it fun and whatnot. So there you go. I guess I should talk a little bit more about absolute zero because I didn't really do that enough throughout the unit. So absolute zero is 0 Kelvin or negative 273 degrees Celsius. This is the lowest temp possible where particles have no energy and they stop moving. And you can probably think, if they're stopping moving, what's that going to do to the pressure because of what it does to the collisions? Okay, this is on page, I believe, 1.4 and 1.5. If that's not right, then it's very close, so you can figure it out. Just look around for it. The other standard, or one of the other standards, is students can use and explain mathematics to convert between units. So I would say there's 3 main, categories of conversions that we've done. Conversions between pressure units, and volume units, I'm treating this as one category. Conversions at STP between liters and moles, and then Celsius and Kelvin, which I would have to say you've gotten very good at doing. Just make sure that if I ask you to show your work, you can show your work for the Celsius and Kelvin. So the pressure units, for instance, would be, I don't know, I've got 3.5 ATM. Let's say I want to go to PSI, so I would have to put PSI on the top because that's what I'm converting to. ATM on the bottom because I need to cancel them out. And then the numbers that go at top and bottom have to be equal to each other. So 14.7 PSI is equal to 1 ATM. And so then you plug this into your calculator and you get something. ATMs cancels out and it's left with PSI. I'm not going to bother doing it. I think the setup is the hard part. Punching in your calculator should not be the hard part. Okay, STP. Let's say we have something, it says it's 0 Celsius and 1 ATM. This tells us it's at STP. And this is on page 11 if you need to reread that. And it tells us, you know, a balloon or a jar of gas or something like that has 0.3 moles of gas. And moles is just a number of particles. So it's telling us how many particles there are. That shouldn't be equals. I want to multiply. So times a fraction. I want to convert to liters, so I'm going to go liters on top, moles on the bottom to cancel moles. And at STP, you have to memorize this number. There are 22.4 liters in 1 mole. So moles cancels out, and again, you get some number, punch it in your calculator, you're left with liters. Celsius and Kelvin, you've got Kelvin equals degrees C plus 273. This will be provided on a reference sheet. So will the pressure equalities. The only thing that you're probably not going to get is I won't tell you what STP is, and I won't tell you 22.4 liters equals 1 moles. You got to remember that. Okay? So let's say I want to convert 500 Kelvin into Celsius. So I just solve for Celsius by subtracting on both sides. Boom, boom. You do your math here, and you get 227 degrees Celsius. The variable is not degrees Celsius, I know this is a little misleading. The variable is temperature, so if you want to write it as equals something, you can say equals T, but the unit is degrees C. Okay, so that's conversions. Okay, last one was combined gas law. It says apply the gas laws. But really, if you know the combined gas law, you know the other 3, which would be Boyle's and all that stuff. This is on page 17, and then the individual laws are on page 12 and 15. I think. I'm going from memory, so if I'm wrong, then I'm close. Okay? And I believe there's actually some extra practice for the combined gas law on page 20 and 21. Again, plus or minus a couple. It's around there. We only did 2 of them, so you've probably got like 4 more that you could do if you need extra practice. Okay, so combined gas law is P1V1 over T1 equals P2V2 over T2. Now let's read and annotate this. A 2-liter balloon, okay, I know liters is volume, is tied to a lead weight and thrown in the Pacific Ocean. Hey, we live by that. Assuming that above the ocean was at STP, aha, so this is actually connected to the previous standard. If the volume decreases to 1 liter at a pressure of 100 millimeters of mercury, mmHg, what is the temperature at that depth? So I'm looking for temperature. So I'm looking for the new temperature, so T2 is question mark. T1, it gives me is, well, it says STP, and so I know STP is 273 K, and then P1 would be 1 ATM, except my units of pressure it gives me are mmHg, so I'm not going to use ATM, I'm going to use 760 mmHg. And as far as remembering standard pressure, remember 1 ATM, and then just look it up on the reference sheet. It'll tell you what 1 ATM is equal to. Okay, and then P2 is the 100 mmHg. V1 is 2 liters and V2 is 1 liter. So now nothing is constant. So I need to plug everything in. So I go 760 mmHg times V1, which is 2 liters. If I'm going too fast, it's a video. You can rewind it. Over T1, which is 273 K, equals P2, 100 mmHg, times V2, which is 1 liters, over T2. We don't write question marks, just write the variable. So now I need to ask myself, do I need to cross multiply? And yes, you do. You always, here I'll put it in a text box here. You always have to cross multiply when the unknown is on the denominator. So I got off the screen there. There we go. All right. So my variable is T2 and it is on the denominator. So I'm going to do that. Here, I'll switch colors for you. So you go like this. Wada boom, wada boom. So that's going to give me 760 mmHg. Don't forget the units. You don't want to leave any naked numbers. Think about what your grandma would say. Okay, so I realized I stopped talking aloud here, but hopefully you followed that. Now I need to get T2 by itself. Listen, whenever you need to get something by itself, do the inverse of the other stuff. Here, I'll write that too. This might not be using proper vocabulary for math, but I think you get what I'm saying. So to isolate a variable, do the inverse of the other stuff. Definitely not great vocab there. Okay, so currently, here I'll switch colors again. Let's do purple. I don't know if you can see the green very well. Okay, currently T2 is being multiplied by 760 mmHg and 2 liters, so I need to get rid of these. I don't need to touch this on the right. I just need to do the inverse. So it's being multiplied. I'm going to divide by both of these. If you want to do this in 2 steps, you can do it in 2 steps, but I don't know what you gain by doing it in 2 steps, except that you do it slower. So all that's gone now, and you get T2. mmHg is gone, liters is gone, and so now I can solve for T2. So I'm going to punch that into my calculator. So here we go, 100 times 1 times 273 divided by 760 divided by 2 liters. Remember, if it's on the denominator, that means it's division. Okay? So now this gives us T2 equals 17.9. Kelvin cancels. Oh no, Kelvin's the only thing that doesn't cancel out. I don't know why I just did that. Kelvin, which is a ridiculously low temperature. And in hindsight, I just realized why. I don't know why. I must have made a typo. I meant to do 1,000, and this is actually 100. Because this doesn't make sense. If you're going beneath the ocean, the pressure should be going up. So I don't want to remake the whole video, but if we did do this to 1,000, you would end up putting an extra 0 here, yeah, and then you just move this over 1. So if it's 100, I did nothing wrong. It is 17.9 Kelvin, but if it's 1,000, it would actually be 179 Kelvin, which is a little bit more realistic. It's still crazy cold because I just made up fake numbers, but it's a little bit better. So if you want to really be a scholar, then write your answer in a sentence. You say the temperature at that depth would be 17.9 Kelvin, or if you do the correction, 179. Okay, remember, this is not the only studying you're doing. You also have the literacy standard. I don't know how to prepare you for this except, build off of the last one. You can look over your old test. Remember, you got to do TAA, use evidence, etc. All right? So I expect to see you and we'll have fun. Bye-bye.